Okay. So for chapter 2, we will talk about the measurement. Okay. Hopefully you will review the PowerPoint slides, review the summary Word document before watching this video. Okay. Measurements. And here we will talk about the scientific notation. So what is the scientific notation? It is a way of expressing really big or small or really small number in a different way. For very large and very small number, scientific notation is more concise. Okay, so how you will write the scientific notation? Scientific notation has two parts. Okay, guys. So it has two parts. Okay, so just 1 minute. As I said, the scientific notation has two parts. The first part, it is a number, which is usually in the range between 1 and 10. Larger than 1 and less than 10. So be careful, guys. Okay? So don't use any number less than 1 or larger than 10. And the second part, it will be a power of 10. So the second part will be a power of 10. Okay. So this is the first part, which is at the symbol N. This, it is in this range, between 1 and 10. Guys, I have some students who use a number here, 0.5, for example. This is less than 1. It's not correct. Or sometimes 11 or 22. This is not correct, guys. Why? Because it's larger than 10. So we need a number in this range between 1 and 10. Like, for example, 1, 2, 2.5, 3.2, 5.6, 9.9, whatever it is, but it's supposed to be less than 10 and larger than 1. Okay, so be careful with this situation. Okay. Let's go to another slides and see what we have. Now, to change the standard from a form to a scientific notation form, what we're going to do? Place the decimal point. We need to move the decimal until we get a number between 1 and 10. Sometimes we need to move the decimal point to the right or to the left. It depends on the number, if it's larger than 1 or less than 1. Count the number of decimal places. How many decimal places did you move the decimal point to get the number between 1 and 10? If the original number was less than 1, so the exponent number will be negative. If it's larger than 1, so it will be positive. Look to this example, guys, here. So we have 30 million. Now, 30 million, there is a decimal point here, even if if they didn't show it to you in the number. Like, for example, I have 5. Is there a decimal point? Yes, it is here, but we don't show it. It's not necessary to show it. We have, for example, 575. Is there any decimal point here? Yes, there is at the end on the right side of the number. Sometimes it's clear and is there, like 3.2. This is the decimal point here. Sometimes they don't give you the decimal point. It's not necessary to show it. It's there on the right side of the number. Okay, now this is the decimal point. Now I need the n part. How you will get n part? What is the n part? It is a number between in the range between 1 and 10. So you will start to move the decimal point to the right or to the left until you will get a number in that range, which is 3.0. I cannot stop here. Why? Because that 30 is larger than 10. So I have to stop here. Okay, now 3.0, write the number. Excuse me. Now, times 10, of course, times 10. Now I need the exponent number. How many decimal places did you move the decimal point? 1, 2, 3, 4, 5, 6, 7. So it will be 7. Now the last things, is it positive 7 or negative 7? Look to the original number. If it's larger than 1, so it will be positive. Less than 1, so it will be negative. Here, 30 million, larger than 1, so it will be positive. So that's how you will write down the scientific notation number. Okay. Here, the same example, we have the decimal point. Now we need to move it to the right until you will get 4.5, which is in the range between 1 and 10. Then how many decimal places did you move it? Here is 5, so put 5 here is the exponent for the 10. Now we need to know if it's negative or positive. Look to the original number, less than 1, so it will be negative. So it will be 4.5 times 10 to negative 5. Now, to change the scientific notation to standard form, the opposite, simply move the decimal point to the right for positive exponent number and move it to the left for negative exponent number. And we will use the 0 to fill in the places. Look here. Okay, sorry, here is some example. Let me give you here an example. Let's say we have, for example, 5.2 times 10 to the power 3. Put 5.2. Now, look at here. Move the decimal point to the right if the exponent positive. Exponent number positive. So here, I will move it to the right. 1, 2, 3. And fill here with 0. So the number, it will be 5,200. Now, if I have 5.2 times 10 to negative 3, 5.2, now I will move the decimal to the left. Okay. And fill it with the 0 and 0.0. Now, it is 0.0052 for this number. So that's how we will do the scientific notation and the standard notation. Okay. Now let's see the significant figure. First of all, how you will count the significant or not significant figure. Here in general, all non-zero digit consider significant. Interior 0, 0 between two numbers, significant. Spelling 0, 0 to the right of non-zero number that fall after the decimal point are significant. Spelling 0, fall before the decimal point, significant. Leading 0 to the left of the first non-zero number, not significant. Spelling 0 at the end of a number, but an implied decimal point are ambiguous. Sometimes we consider it significant, sometimes not. Here, if there is no decimal point, we will consider it not significant. Okay, now just one thing here, guys. When we have some exact number, this exact number, like the number also that exists in the conversion factor, these, they have infinite significant figure. Okay, so for example, here I have 60 minutes in 1 hour. That means it is 60.0000000 infinity 0. Okay, that means it has infinite significant figure. Usually, when we are dealing in our calculation, when we have a conversion factor, don't look for the conversion factor, how many significant figures there. So for example, I have 60 minutes in 1 hour, so I cannot say 1 here, it is only one significant figure. No, because this 1 hour, it is 1.00000. Okay, so when you are dealing with the calculation and looking for the significant figure, don't look for the significant figure of conversion factor. Okay, now let's look for the rule, how to using the significant figure in calculation. Okay, in the multiplication and division, the result will have the same number of significant figure as the factor with the fewest significant figure. So for example, here, I have this multiplication, 3 significant here, 5 significant, 2 significant. My answer should have only 2 significant. Do your calculation in the calculator, you will get this number in the blue color. Then you will round up that number to 45 only, 2 significant. Okay, now in division, the same things. I have 4 significant figure here, 3 significant. Do the calculation in your calculator, you will get the number in the blue. And you will round up that number to have only a 3 significant figure, because I have 4 and 3, so it will be my answer 3 significant. In the addition and subtraction will be the same thing, same rule, but with the decimal places, not significant figure. Be careful, guys. So here I have this addition. This has 2 decimal places, not 3 significant figures. I'm not in the addition, subtraction. Don't look for the significant figure. Look to the decimal places. I have decimal places for 6, not decimal places for 4. Here, 3 decimal places. Here, 3 decimal places. My answer should have only 2 decimal places to the math. Then you will round up that number to 9.21. Don't tell me it is a 3 significant figure here and 3 significant, 4 significant, and my answer will be 3 significant. Sometimes it's working, but not always, guys. The rule, it is with the decimal places. Look at here. I have 1 decimal places, 3 decimal places. My answer should have only 1 decimal places. So be careful between the calculation, between the division or multiplication and addition and subtraction. Okay, now, if we have both multiplication, division, and addition, subtracting, we will do inside the parentheses first, and then we will finish the calculation. So here, for example, I have 3.489 times parentheses here subtracting. First of all, we will get 5.67 minus 2.3. Do the calculation. Don't round up the number, guys, during the steps. We will round up only on the last step. Okay, so here 5.6 and 5.6 here. 67, sorry, minus 2.3, we will get to 3.37. Don't round up the number, but you have to keep in your mind, here I have 1 decimal places, 2 decimal places here for 5.6. So my answer should have 1 decimal places. So my answer should have only 1 decimal places here. That means if you will do the multiplication with this number, we will go with the significant figure. That means this number has 2 significant. And this one, 4 significant figure. My answer should have only 2 significant figure. And that's what is it work. Okay, in the metric system, we have some prefixes. Try to be familiar with these from now, okay? We have some exponent positive, okay? Multiplied by positive exponent number or multiplied by negative exponent number. So be familiar with these prefixes because we will start to use it a lot in our class. Conversion factor. The conversion factor is a fraction in which the numerator and denominator are equal quantities but expressed in different units. So for example, 1 inch equal 2.54 centimeter. So here we can write that conversion factor as a numerator and denominator. So we can say 1 inch numerator divided by 2.54 centimeter in the denominator, or 2.54 centimeter in the numerator and 1 inch in generator. So that's how we will write down this conversion factor. Here this table, it will tell you about the most common conversion factor that we will deal with it in our class here. So for example, 1 pound has 453.6 gram and 1 inch 2.54 centimeter, and some other conversion factor in the metric and English system. Okay, now, how you will do the conversion factor? We have something it's called the dimensional analysis. The dimensional analysis is a good way to do the conversion for the unit. So look here, guys, how you will do the dimensional analysis in your calculation for the conversion factor and the other calculation. We will use it also a lot with other calculation. Usually, we have a given number with a given unit. So this is the given unit. Start with it, then times your conversion factor. Now the question is how you will write down the conversion factor is very important. So for example, if you remember the previous conversion factor, the inch, we can write it down either as inch in the top and centimeter in the bottom, or the opposite, centimeter in the top, inch in the top, centimeter in the top and inch in the bottom. So which way you will use, which one you will use? Both of them, it is the same, it is the same conversion factor, but who you will write it is very important. In the dimensional analysis, we will learn to write the conversion factor by this way. As I said, you will start with the given unit. Of course, here, for this given unit, the denominator is equal 1. Times conversion factor. We will put the desired unit, what they are asking, the asking unit, we will put it in the top. And in the bottom, we will put the given unit from the conversion factor. To be able to cancel this given unit with this given unit, and we will get the desired unit. Okay? It is the same as the given divided by 1, the required, or what they are asking, divided by the given. If we have to use more than one conversion factor, we have to arrange it in this way. So this is the given, okay? Times the given 1 divided by given 2. To cancel this given 2 with this given 2. Then times another conversion factor, the required, what they are asking, divided by given 1. Cancel given 1 with given 1. Do the cancellation, and we need to end up with the required unit or the asking or desired unit. So this way, it is a good strategy to deal with these calculations. As I said, we will use it here in this chapter for the conversion factor, and also we will do it later in other calculations. So look to this example. How many kilograms are in 5,000 ounces? Okay. Now, they give you each 1 pound equal 454 grams approximately, and 16 ounces equal 1 pound. Now, start with the 5,000. This is the 5,000 pounds. This is the given. Times. Okay. We have to convert this to kilogram, but we have only the conversion factor between a gram and pound. And then they give us also ounce and a pound. So first of all, let's convert the ounce to pound. How do you write it down? The pound, 1 pound in the top, 16 ounce in the top and the bottom. Times, we need to convert the pound to gram. So here, the 454 grams in the top, the 1 pound in the bottom. Now be careful, guys, they are asking to convert it to kilogram, so we need to continue. Remember the prefixes that I told you that you have to memorize them. You know, at least the most common, like the kilo, the mega, micro, there is a lot of common prefixes. We need to be familiar with it right now. The kilogram, 1 kilogram equals 1,000 into power 3 gram. So here, how you will write it down? And by the way, guys, these prefixes, you have to memorize them. Sometimes in some question, they don't give it to you like these conversion factor. Okay, so the gram will be in the top, in the bottom, sorry. So 1,000 gram here, and 1 kilogram in the bottom. Now I will be able to cancel it with a pound with a pound, gram with a gram. Do the math. Okay, you will do the math later. Okay, I just want to go and give you some other examples. So you will do the math and your unit will be kilogram. Okay. That's how you will do this calculation with the dimensional analysis. Okay, let's look to another example here. 3.65 times 10 to the power 5 microsecond. How many kilosecond in this? Start with a given 3.65 times 10 to the power 5 microsecond times. I will convert it to second terms. Okay, how you will convert it? Each 1 second has 10 to the power 6 microsecond. So here I will put the 10 to the power 6 microsecond in the bottom and 1 second to the top. And now I need to convert it to kilosecond. 1 kilosecond equal 1,000 second. The kilo always 1,000. So we will write it down. I will put 1,000 second here and 1 kilosecond here. And so second with a second, microsecond with a second, microsecond, and your answer will be in kilosecond. Of course, you need to do the math. Now, 25 picogram. How many centigram? Start with the 25 picogram times. Each 1 gram equal 10 to power positive 12 picogram. And also 1 centigram equal 10 to power negative 2 picogram. How you want to do it? Picogram, so you will put it here 10 to power 12 picogram in the bottom, 1 gram in the top, times here 10 to power negative 2 gram, 1 centigram in the top, cancel a gram with a gram, picogram with a picogram, your answer will be 1 centigram. My advice, guys, for you, try to practice a lot with these conversion factor, okay, and how to use the dimensional analysis to solve these type of problem. Okay, I already have a lot of example in the PowerPoint slides, and also in the lecture note also we have an example, so try to practice a lot. Beside you exercising the homework in the Kimo now and that. Okay, now how you will deal when we have a unit raised to a power, like square, cubic, or other power? Be careful, guys, here. When you will convert the unit with the power, you have to raise everything in the conversion factor to that power. Not only the unit, but also the number. So for example, converting 200 cubic inch to millimeter. So here, what you're gonna do, 200 inch cubic. I will convert the inch to centimeter first. Each 1 inch equal 2.5 per centimeter. So here 2.5 for centimeter 1 inch. But be careful, guys, here there's a cubic. So I will raise everything here to the cubic. That means this cubic it will be for the centimeter and for inch. And for the number also 2.54 to power 3 and 1 to power 3. Then I will convert the millimeter. Each 1 cubic centimeter give me 1 millimeter. Do the math and you will get the number here. 3277.4, 2 milliliter. Be careful, guys, with the significant figure. Look at here. Just look for the number with the given information. So what they give you? 200 point. So we have 3 significant figures. So my number supposed to be 3 significant figure. Here supposed to be, yeah, 3,280. There is no decimal point, so we have only 3 significant figures. Okay, don't look for the 1 or 1 here or 1 here or this one in the conversion factor, because they have an infinity decimal infinity significant figure. Okay, so don't tell me the lowest significant figure or the fewest significant figure here. It is 1 because we have 1 no, or 1 cubic centimeter or 1 inch. No, this one it is 1.00000 infinity 0. Okay, so just look for the original number, how many significant figure. Your final answers will be the same significant figure. Okay, next subject we have the density. Okay, so let's go to density. Density equal the mass divided by the volume. And the unit, be careful with the unit, will be the unit of the mass divided by the unit of the volume. Unit, the common unit, there is gram per cubic centimeter or gram per milliliter, but it could be any unit of the mass divided by the unit of volume. Be careful, guys, here how you will measure the volume. Sometimes we can measure the volume from the calculation, the dimension, like volume equal the length times the volume times width times the height. Okay, or volume of cylinder or whatever it is, we can do it from the calculation. But also we can calculate it from the water displacement, especially if we have irregular shape that we cannot measure the dimension from. How you will do it? You have specific level of water, for example, with a specific volume here. Let's say, for example, I have 300 liter, for example. You will put that irregular shape inside the water. And of course, the water will raise to a new level. Let's say here, for example, it is 380 liter, for example. So what the volume of that object here? So that volume will be the 380 minus 300, give you 80 liters. So the difference is the water displacement. So that's how you will measure the volume, especially for irregular shape. I will say sometimes with the regular shape we can calculate the volume from the calculation from the dimension. So look to this example. Density of density of aluminum is 2.7 gram per cubic centimeter. They give us the density, and lead it is 11.36 gram per cubic centimeter. You find an object that weighs this amount in gram and has a measurement 10 centimeter, 12, 15. With this shape is regular shape is the object you find lead or aluminum. So you can decide from the density. So you can calculate the density for the mass divided by volume. The mass here is 2,500 grams, 20,500 grams divided by the volume. What is the volume? So look at here. This is regular shape, okay? So we will calculate the volume from the length, width, times the height. So it will be 10 times 12 times 15. Do the math here. We will get the volume in a cubic centimeter, because this is centimeter, centimeter, centimeter. So my answer will be cubic centimeter. We'll use the volume here, and then whatever the density you will get it, you will compare it with the density of the lead or the aluminum to decide what do you have for that object, what the object that you find, what it is. Okay. Let's look for another example here. Okay, let's look at this example. Okay, you discovered the piece of matter that looked like gold. Density of gold as this, but it may be for gold. Density of this could be. The sample mass is 112 grams. When you place it in a graduated cylinder here, containing 35.8 milliliter of water, the water level raised to 6. So the water level raised. Calculate the density of the sample identified. Okay, guys. So here, do the same things that we did in the previous example. We need to compare the densities. So density will equal the mass divided by volume. The mass, it is 112 grams. Now, the volume. What is the volume? Is it this one, the 35.8, 41.6? Neither of them. It is the difference, guys. Okay, so it is 41.6 minus 35.8, and that will give you 5.8 milliliter. 5.8 milliliter. Put it here, and you will get here whatever the result, your density in gram per milliliter, which is the same as gram per cubic centimeter, equals 1 milliliter equal 1 cubic centimeter. And you will compare it with either the density of the gold or the gold. Here I think it will be gold. It will be around 20. So I think it will be gold, just the mass, the vaccines. Practice a lot also with the density problem. It is very important in this chapter, so try to practice a lot. We have a lot of example in the PowerPoint slides, in the lecture note, in the example PowerPoint slides that I posted in the Canvas, so try to practice a lot. Okay, guys, so I will see you in another video.